Imagine if every time you wanted to remember your own mother's birthday, you had to write a letter.
Oh, that sounds terribly inefficient.
Right. You write it, put it in an envelope, mail it to this massive climate-controlled warehouse out in the middle of the desert somewhere.
Just to get a date.
Yeah, and then you just sit around waiting for some librarian to mail the answer back to you. It sounds completely absurd.
It really does.
But for the last decade, that is essentially how our artificial intelligence has been functioning. Every prompt you type, every question you ask your phone, it all gets packaged up and shipped off to a distant server farm.
Exactly. We've been living in this era of centralized intelligence.
Yeah.
The prevailing logic was always that to handle the immense computational weight of large language models, you needed acres of humming servers.
Massive cooling towers, gigawatts of power.
Right. You needed the digital equivalent of a skyscraper.
Well, the construction crews are packing up.
They really are.
The entire tech landscape is experiencing this architectural shift that completely upends that old logic. AI is leaving the monolithic server farms and moving directly into the hardware sitting on your desk.
Or even the phone resting in your pocket right now.
Yeah, exactly. Welcome to today's deep dive. We are thrilled you're joining us because our mission today is to examine this fundamental structural shift in the very architecture of artificial intelligence.
It's a huge topic.
It is. And we're pulling our insights from a genuinely eye-opening piece of source material by Virtual Protocol. It's titled The Local Intelligence Revolution.
And it's a text that maps out a transition affecting, honestly, every single piece of technology you interact with. Virtual Protocol makes the case that we are moving out of the cloud era and squarely into the local era.
Yeah, and this isn't some distant futurism either.
No, not at all. The migration is happening right now across laptops, smartphones, and, dedicated edge devices.
Okay, let's unpack this because Virtual Protocol makes it very clear that this isn't just an incremental software update you install overnight while you sleep.
Definitely not.
This is a total redefinition of how we interact with technology.
Yeah.
But to understand why AI is packing its bags, we first have to understand why the cloud is suddenly becoming a structural bottleneck.
What's fascinating here is that the cloud gave AI its initial massive scale. You absolutely needed those centralized resources to train the models on, trillions of words.
Because training requires ridiculous amounts of compute.
Right. But deployment is a totally different story. The source text outlines several severe limitations we are just crashing into when we try to deploy AI exclusively through the cloud.
And the most immediate one is latency, right?
Yes. That digital commute we were just talking about, sending your data across country.
Even traveling at the speed of light.
Yeah.
Data isn't moving through a vacuum.
Exactly. You are routing a request through local cell towers, jumping across fiber optic cables, sitting in massive server queues.
Waiting for a processor to actually generate an answer.
Right, and then making the entire journey in reverse. We are talking about hundreds of milliseconds, sometimes even seconds.
Which doesn't sound like a lot on paper.
No, but in the context of a real-time voice-to-voice conversation, those milliseconds feel like an eternity.
Oh, absolutely. It completely breaks the illusion of a seamless interaction. Nobody wants to have a conversation with someone who just stares blankly for 3 seconds before responding to every single sentence.
Yeah, it makes the technology feel incredibly sluggish, even when the underlying intelligence is staggering.
And then there's the fragility of the whole system. The source points out our total dependence on centralized infrastructure. Think about it.
Oh, it's a house of cards.
Yeah. If your cell service drops out on a road trip, or if the cloud provider experiences a server outage, your highly advanced $1,000 smart device instantly becomes a very expensive paperweight.
A brick.
Yeah.
No internet connection basically means zero intelligence. You're completely tethered.
And we haven't even touched on the privacy implications yet.
Oh, right. Sending every passing thought, every rough draft, every awkward medical query to a centralized server.
It's a lot. We will get into that for sure. But the shift to local processing solves the latency and the tethering issues instantly. By eliminating that round trip, the response time drops to near zero.
It's practically instantaneous.
But, I'm looking at this from a purely logistical standpoint. I want to push back on this a bit.
Sure, go ahead.
Because if we are cutting the cord to these massive cloud servers, the massive supercomputers that made these models smart in the first place, doesn't that inherently mean our AI is going to become less powerful?
It's a fair question.
right? Because we have been told for years that size equals intelligence in machine learning. So aren't we just trading actual brain power for the convenience of working offline?
That is the most common hesitation, and it's a highly logical assumption. I mean, if you shrink a massive brain down to fit inside a laptop, you assume you lose the intelligence.
Exactly.
But the industry didn't just take a massive trillion-parameter cloud model and try to awkwardly compress it onto a smartphone.
That would be a complete disaster.
It would just crash the phone. The solution described in the text required a total redesign of both software and hardware working in perfect symbiosis.
Well, let's break down the software side first, because the source talks about a new generation of models. They aren't just like zipped files.
Right, they're structurally different.
Yeah. I've been reading about how developers are using techniques like quantization to shrink these models.
Quantization is key here.
Instead of the AI using massively complex memory-heavy numbers like 32-bit floating point numbers to make its calculations, they round those numbers down to smaller 8-bit or 4-bit integers.
It is entirely analogous to taking a massive, uncompressed raw photograph and converting it into a highly optimized JPEG.
Oh, I like that analogy.
Yeah, the file size shrinks by a factor of 10, but to the human eye, the image looks virtually identical. The core intelligence, the reasoning capability of the model, it remains largely intact even when the mathematical precision is slightly rounded off.
And then you add pruning to that, where they actually sever the neural connections in the model that rarely get used, and suddenly you have this streamlined, hyper-efficient model.
Exactly. It doesn't need to hold the entire internet in its memory to be useful. It becomes a specialist.
So the software got incredibly lean.
Very lean. But, you still run into a physical wall if you try to process even a lean AI model on standard computer hardware.
Because of the CPUs.
Right. Traditional processors, your CPUs, are built for sequential logic. They are brilliant at executing one complex instruction after another.
But AI inference doesn't work like that, does it?
Not at all. AI requires matrix multiplication. It's calculating millions of very simple probabilities all at the exact same time.
I was trying to wrap my head around this difference earlier, and tell me if this tracks.
Let's hear it.
Think of a standard CPU like a genius polymath. It can solve any complex, multi-layered physics equation you throw at it, but it takes its time doing them one by one.
Okay, yeah.
But if you hand that polymath a stack of 3 million basic addition worksheets, they get completely bogged down.
Exactly. They choke on the sheer volume of simple tasks.
Right. But the hardware revolution Virtual Protocol highlights is the introduction of neural processing units, or NPUs.
Yes, the NPU.
And an NPU isn't a polymath. An NPU is like an army of 10,000 kindergartners doing basic addition simultaneously.
Oh, that is a phenomenal way to visualize parallel processing.
Right. It gets the massive parallel job done instantly without burning out the genius CPU.
Modern devices are now shipping with these dedicated NPUs baked directly into the silicon. Their entire architectural purpose is to do the specific type of math that AI requires.
And they do it incredibly fast.
Incredibly fast. Without ever phoning home to the cloud, the NPU clears the bottleneck entirely.
But here's my hang-up with all this optimized hardware. We all know from experience that complex computing completely drains battery life.
Oh, absolutely.
I mean, if I leave too many browser tabs open, my laptop fan sounds like a jet engine preparing for takeoff, and my battery dies in 45 minutes.
We've all been there.
So how does this impact the energy efficiency of our devices if they are constantly thinking with these new NPUs? The Virtual Protocol text specifically mentions the delicate balance between performance and energy efficiency.
Well, the secret lies in the architecture we just discussed.
Sure.
Because the NPU is built specifically for parallel matrix math, it doesn't have to work nearly as hard as a CPU would to achieve the same result.
This is not redlining all the time.
Exactly. A traditional processor has to wake up, pull high wattage to execute a task it wasn't really designed for, and then go back to sleep. The NPU operates at a vastly lower clock speed.
It sips energy rather than gulping it.
Precisely.
So the thermal output is lower, the power draw is negligible.
And that low power consumption is the linchpin of the entire revolution. Because the NPU isn't draining your battery in 20 minutes, these local AI models no longer need to be actively turned on and off.
Really?
Yeah, they can run perpetually in the background.
Okay, here's where it gets really interesting, because Virtual Protocol argues that this specific hardware efficiency leads to something radical. They call it the death of the app as we know it.
It's a huge paradigm shift.
Up until now, AI has been highly transactional. It's a tool you retrieve from a shed. You actively open a browser, navigate to an interface, type out a prompt, and wait for a response.
Right. It requires conscious engagement every single time you want value from it. You are initiating the relationship. You serve the AI.
But with local, low-power MPUs, the source introduces the concept of ambient intelligence.
Yes.
The AI stops being a discrete application and becomes a continuous background layer of the operating system itself. It's always available, always processing the context of your screen, and always assisting without you ever having to actively ask it to.
The text highlights a few striking examples of this transition: real-time transcription, contextual recommendations, autonomous task execution.
It sounds like magic.
But we need to unpack what that actually looks like in practice, because the shift from transactional to ambient is massive.
Let's make that real for you, the listener.
Yeah.
Imagine you are sitting in a chaotic virtual meeting. You aren't taking notes. You haven't opened an AI app.
You're just listening.
Right. Your ambient intelligence is securely running in the background, listening to the audio stream. Someone on the call mentions they need the revised budget figures for Q3.
Okay.
Before you even touch your mouse, the AI understands the context of the conversation, searches your local hard drive, pulls up the specific Excel sheet, and highlights the Q3 column on your screen.
That's incredible.
It anticipated the need based purely on the context of your ongoing activity.
And it goes further. It drafts the email response while you are still reading the incoming message. It organizes your scattered desktop files based on the project you are currently focused on.
It's doing the busy work.
Exactly. It marks the beginning of a truly seamless interaction where the machine adapts to the human workflow rather than forcing the human to adapt to the machine's interface.
It sounds incredibly convenient, but I know what you're thinking as you listen to this.
Yeah.
Always processing and always listening sounds profoundly creepy.
Oh, yeah. It triggers all sorts of alarm bells.
If we were still operating under the old cloud model, this would be an absolute dystopia.
That total nightmare.
Imagine a cloud-based AI recording your microphone, reading your screen, capturing your passwords, and sending a live, unencrypted feed of your entire digital life up to a centralized server farm just to suggest a calendar event.
It would be a catastrophic data mining vulnerability. Literally the ultimate surveillance apparatus willingly installed by the consumer.
And that brings us to the most crucial pivot in the source material. Ambient assistance is only safely possible because of the local privacy paradigm.
Right.
Absolute, uncompromising trust is a hard prerequisite for ambient intelligence. If this system is going to watch me type my banking passwords, read my medical history, and analyze my private text messages to help me schedule my day, I need mathematical certainty that nobody else can intercept that data.
And that certainty is exactly what local processing provides by physically cutting the cord.
It changes everything.
The security model fundamentally flips. The source text stresses that when AI operates via an on-device NPU, your sensitive data never leaves your hardware. There is zero transmission of personal or proprietary information to external servers,
So the perimeter of your data is just the physical casing of your laptop.
which drastically mitigates the exposure to data breaches, to network interceptions, or, to unauthorized access by the tech companies themselves.
That makes total sense.
Think about the implications for critical industries, finance, healthcare, government. Right now, if a doctor wants to use a cloud-based AI to summarize a patient's complex medical history, they have to navigate this labyrinth of compliance regulations.
Oh, APA alone is a nightmare.
Right, data security agreements, anonymization protocols, just to legally transmit that data to a third-party server.
It's a massive compliance headache. But if the intelligence model runs entirely locally on the doctor's proprietary NPU-equipped tablet, the patient data never touches the open internet.
Exactly.
The compliance risk essentially evaporates because the data never moved.
As Virtual Protocol clearly states, on-device AI doesn't just improve computational performance, it fundamentally re-engineers digital trust.
Yeah, and if we connect this to the bigger picture, this is about so much more than just keeping your personal text messages out of a server farm.
It really is.
This is a conversation about the distribution of power. This migration from the cloud to the device is signaling a massive decentralization of artificial intelligence.
A total shift.
For the last 10 years, a very small handful of massive tech companies with the deepest pockets and the biggest server farms have effectively controlled the entire AI ecosystem.
They held all the cards because they owned all the infrastructure. They dictated the terms of access, the pricing, the acceptable use policies.
I had to play by their rules.
But when the actual processing power, the engine of the intelligence, migrates to billions of individual edge devices, that monopoly fragments.
Wow, yeah.
Control shifts away from those centralized platforms and moves directly into the hands of individual users and independent organizations.
It democratizes the technology.
Exactly, reducing global dependency on those mega providers and paving the way for a much more diverse, distributed kind of innovation.
So what does this all mean? I mean, I hear words like decentralization and democratization, and it paints a very utopian picture.
It sounds great on paper.
But let me push back on this vision, because the logistics of this seem terrifying from an engineering perspective.
They are daunting.
If we actually decentralize AI away from these heavily monitored, highly controlled cloud servers and push the intelligence out to billions of individual, completely disconnected edge devices, how on earth do developers manage that ecosystem?
You're hitting on the exact friction point that Virtual Protocol identifies as the defining challenge of this new era.
Yeah.
It is the double-edged sword of decentralization.
Because in the cloud, developers have absolute control. If a model starts hallucinating, or if a critical security flaw is discovered, the engineering team can patch the centralized model instantly.
Yep. One fix, deployed universally, and the problem is solved for everyone worldwide at the exact same moment.
They control the silicon, the memory constraints, the temperature of the room. It is a sterile, perfectly managed environment.
But locally, you are dealing with an incredibly fragmented hardware landscape.
It's chaos.
One user is running the AI on a brand new machine with 32 gigabytes of RAM. Another is trying to run it on a 3-year-old phone with a degraded battery.
Right, you have different operating systems, varying levels of security hygiene, and, users who refuse to download software updates for months at a time.
Securing a massive data center is difficult, sure, but you have a defined perimeter. Securing 3 billion individual smartphones sitting in people's pockets, connecting to unsecure public Wi-Fi networks in coffee shops.
While maintaining the integrity of the AI models running on them.
That is an infinitely more complex security topology.
And what about model drift? If your local AI is learning from your specific data, adapting to your specific writing style and habits over time, it diverges from the original baseline model.
It becomes highly personalized, which is the point, but
if a malicious actor figures out a way to exploit an open-source local model, there is no centralized authority to hit a global kill switch. You are relying on the user to understand the threat and apply the patch.
the logistics of managing model updates, version control, and security at that massive scale without violating the very local privacy that makes the system appealing in the first place, that is the puzzle the industry is desperately trying to solve right now.
Because you can't just forcefully pull diagnostic data from a device if the entire selling point of the device is that it never sends data back to the mothership.
It completely breaks the premise.
Okay, well, we have covered a tremendous amount of complex ground today. Let's take a moment to recap the core takeaways we've explored from the local intelligence revolution.
Good idea.
We are currently living through the twilight of the cloud-only AI era. We are entering a fundamentally new paradigm where intelligence is highly personal, deeply private, and permanently integrated into the background of our devices.
Thanks to those hardware upgrades.
Yes, this is made possible by highly efficient, pruned-down software models working in tandem with dedicated hardware, specifically neural processing units.
The NPUs.
We're moving away from clunky, transactional applications that drain our batteries and stepping into a world of seamless ambient intelligence that anticipates our needs while keeping our data locked safely on our own devices.
This raises an important question, though, and it is the exact thematic question that Virtual Protocol focuses on as this architectural shift accelerates. If intelligence lives entirely on your device, who truly controls it?
It's a heavy question.
Yeah.
But I want to take that idea of control and decentralization one step further for you, the listener, to mull over as you go about your day. Throughout this deep dive, we've talked extensively about autonomous task execution.
Mm-hmm.
Your ambient AI, sitting locally on your NPU, operating quietly in the background.
Doing the busy work.
Right. It's drafting your emails, organizing your sensitive files, maybe even executing financial trades or paying invoices based on parameters you set up months ago.
Which is incredibly helpful.
Because it's local, it's fast, and it's autonomous. But if it operates entirely in the background without your active prompting, and it makes a highly consequential error, who is responsible?
That is the million-dollar question. The shift in processing architecture inevitably forces a massive shift in legal and ethical accountability.
Exactly. If the AI lived in the cloud and made a catastrophic mistake, you could perhaps point the finger at the massive tech giant that built and hosted the centralized model. their server, their liability.
Right.
But if the control has truly decentralized and the intelligence physically lives on your personal hardware, learning exclusively from your private data, operating completely offline, does the liability shift directly to you?
It's a scary thought.
If your local ambient AI misinterprets a context clue, sends a disastrous communication, or makes a flawed financial decision, are you on the hook for the fallout, even if you never explicitly pushed a single button to approve the action?
When you remove the centralized authority, you also remove the centralized safety net.
We started today by talking about moving away from the centralized digital skyscrapers and returning to local architecture. It turns out when you own the building, you also own the liability if the roof caves in.
Well said.
We want to thank you so much for joining us on this deep dive into the shifting tectonic plates of artificial intelligence. Keep looking closely at the technology, quietly running in your own pockets, because the revolution isn't somewhere in a distant cloud. It is already sitting right there on your desk.